Welcome to Chapter 4 Ratio, Proportion, and Percent. This video is covering Section 4.4, Percent Problems, and is a continuation of previous videos for Chapter 4. In this video, we are going to look at solving problems involving percents and solving applications involving percents. Matter of fact, about the next 3 videos, we will be covering this. So this is going to be a foundational video, and I hope this is really going to help. The technique that I'm going to show you is different from the book. I'm not saying it's any better, but it's different, so you have an opportunity to learn 2 different ways. For many of my students, the way I'm going to show you is very helpful because, again, it goes back to translating word problems into mathematical problems. And so let's go ahead and I'll just give you a little bit of a demonstration here. So when we're looking at percent problems, you'll see that there's 3 basic types of problems, and they're going to be all really mixed up, and you'll see that they're used in business, technology, trades, medicine, cooking, is all over the place. You're going to see these types of problems, and once we get into the problems, you'll identify these problems as something that's very, very common, and hopefully this will be very useful to you. So what I'm going to introduce to you here are some words and their math translations. So when you see the word is, think of it as equal to. When you see the word of in the problem, think of it as a multiplication sign. And when you see in the problem either the words what number, a percent, they want you to find something, there's an unknown quantity, then think of that as a variable, and you can name that variable whatever you like to. So let's go ahead and look at the first problem. We're going to look at the first problem where it says, what is 30% of 50? And I wouldn't doubt if some of you are cringing, like, oh my gosh, I remember these. I hated these because they were so confusing. I never knew what to do. Hopefully this is going to make it a whole lot easier because we're going to translate this together. And so let's go ahead and see that it says, what is, all right, so what is a variable, and so I'm just going to call this x. What is, so what is equals, right? What is x is equals, they've given me this 30% here, of is times, and 50. So, all right, let's see if this works out. X equals 30% times 50. Well, I can't multiply percentage, but I remember from the last episode and video that if I take this percentage sign and I move it over 2 spaces and I put my decimal there, then that is actually translates into x equals 0.3 times 50. And then so if I go ahead and get my handy dandy calculator and I figure this out, then I can say 0.3 times 50 equals 15. So x equals 15. Okay, here's something I want everybody to do. Please make sure to always go back and look and say, does that make sense? All right. What did the original problem say? What is 30% of 50? Well, I know 30% is less than 50%, so it's less than half. 50% of 50 would be 25, so x is 15. That's less than 25. Yeah, that makes sense. So hopefully that helps, and we're going to move on to the next problem. So here we have another problem. This one is a little bit different. This is not asking a question so much as giving us a directive. It says find 8.5% of 160. Well, all right, well, let's go ahead and follow the instructions like what it says. Using the translation tool, we will say, okay, 8.5% of, And so of is times 160. All right, so what is 8.5% of 160? Well, remember, we can't multiply percentage, at least most of us can't in our calculators, and it's good practice to go ahead and put it into a decimal form. And so in this case, we're going to move our decimal over. Remember how we did that? Like over 2 places, but that doesn't quite work with that. So what we need to do is we just need to remember that what this really is it's 0.085, because that's a half, times 160. And so if we do that, and we get the calculator, and we say 0.085 times 160, that the answer should be 13.6. And so is 13.6 8.5% of 160? Does it make sense? Let's see, 8.5% is less than 10%. 10% of 160 would be 16. So yeah, 13.6, yep, that makes sense. So the next problem we are going to look at 5 is what percent of 8. So the problem says 5 is what percent of 8. Go ahead and pause your recording right now if you'd like to go ahead and try this on your own. All right, let's go ahead and attack this problem, and we're going to bring this down and say, after translation, that 5 is or equals what percent, so we'll say y, we don't really know, of 8. And so we say, okay, well, to be able to solve this, we're going to say 5 equals 8y. And so let's go ahead and isolate the variable by bringing y down, 5 over 8. And y is going to be, our handy dandy calculator, 0.625 equals y. And then now we're going to go ahead and go up here to finish this problem. And remember that 0.625, we need that as a percent, so we'll move the decimal over 2 places and get 62.5% equals y. And then we'll go back and check it. Does that make sense? So the problem stated 5 is what percent of 8? Well, let's see. 4 is 50% of 8. So if 62.5 is 5, yeah, that makes sense. All right. We'll go ahead and move to the next problem. So with this problem, it is asking 8.7 is 30% of what number? So go ahead and pause your recording if you'd like, so you can try this one on your own. All right, let's go ahead and just jump into it then. If you've already done this, great. Let's go ahead and check it. 8.7 is or equals 30%. Now we're going to remember that 30% is 0.30, so I'm just going to put it right there, of x. All right, so now we're going to get rid of this, and we're left with x. What we do to one side, we have to do to the other. So let's see, 8.7 divided by 0.3 equals 29. So let's see, let's check that. Does that make sense? Around about 8.7, 30%, so 50% of 29, 30 about 15. So yeah, it sounds just about right. We can always also take it and doing it the other way too, and doing a check of going 29 times 0.3, or 30%. And so go back the other way that we just did. and we're left with 8.7. So we can say that that is correct. All right, move on to the next problem. So in example 5, we're going to incorporate what we've been doing and how we are learning to be able to use our terms of and is and decipher it in problems. So go ahead and read the problem. Actually, I'll go ahead and read the problem. A moderately active adult weighing 175 pounds needs to consume about 2,800 calories per day in order to maintain his or her weight. A nutritionist recommends that no more than 30% of those calories should come from fat. What is the maximum number of calories per day that should come from fat? So now I'll go ahead and pause. Please reread this, read it again, try to find the factual information that you need from this problem. If you'd like to go ahead and try to solve it after that, great. If you get a little bit stumped, that's okay. We're going to learn about it, but I want you to at least read the problem until you can figure out what it is asking for. And also, I want you to read the problem to see what's extra information that they gave to you here. I'll go ahead and pause for a minute. Okay, so let's go ahead and look at this problem and read it for facts. And so it says a moderately active adult weighing 175 pounds needs to consume 2,800 calories per day. The question down here says, what's the maximum number of calories per day should come from fat? Well, nowhere in there does it say anything about how much a person needs to weigh. So adult weighing 175 pounds, that really isn't information that it's even asking for in here. So we're just going to get rid of that and stick with what we know. So we know that adults need to consume about 2,800 calories per day to maintain their weight, and that they need to get no more than 30% of those calories from fat. So what's the maximum number of calories per day that should come from fat? So let's go ahead and look at this and really rephrase this, and you'll see this is something that we're going to do. So what we really want to ask is, when it says what are the maximum number of calories per day, well, we know that the maximum number of calories is 30% of 2,800 calories. So we're going to see what is 30% of 2,800. And by doing that, of course, we now have it in a form that we can mathematically figure out. And we'll say, what is 30% of 2,800? So 0.30 times 2,800. And we get our calculator out. We'll go 2,800 times 0.3, and we come up with 840 calories from fat per day that an adult should consume. So hopefully that made sense. Go back and look at that again if you need to. So remember, we're deciphering what is it that it's asking and how can we put it and rephrase it in a way that we can solve the problem. Let's go and look at the next problem. So in this case, a builder told his crew that the site preparation and foundation work on a house would represent about 5% of the total building time. If it took the crew 21 days to do this work, how long will the entire construction take? And so go ahead and pause the video, read this again, reread it, and look for the facts. Okay, so we're looking at this, and a builder told his crew that the site preparation and foundation work would be about 5% of the total building time. So a very small amount of time is just on the foundation and preparing the site. So if it took them 21 days to do the work, how long will the entire construction take? So let's go ahead and we're going to rephrase this again, and we're going to say then, what is 21 days, or 21 days is 5% of the total building time, because that's what this says. It says 21 days is 5% of the total building time. So if we have it written out like that, then we can go ahead and do our translation and say 21 equals 0.05 of the total building time, which we don't know what that is, so we'll call it T. And so we want to go ahead and solve for T. What we do to one side, we have to do to the other. This goes out. We're left with T. 21 divided by 0.05. And we're left with 420 days. And I didn't do this on the last one. I should have. I kind of just did a mental check, but with this one, we'll go ahead and look at the check. Does it make sense that it would take 420 days, that 21 days is 5% of the total building time if the total building time is 420 days? So yeah, I mean 10% of 420 days is 42, and that's half of that, so 21 days. Yep, that makes sense. Sounds like that is a reasonable answer. Good job. So the next problem is from the health sciences, and we're going to look at a problem that's a little bit more complicated. And so I want you to go ahead and read the problem along with me. 12 milliliters of acetic acid, basically vinegar, are mixed with 38 milliliters of water. They want to calculate the percentage concentration of the resulting solution, so the two of them together. And the question is, what percent of the solution is acetic acid? I want you to think about this a little bit, go through, and really I want you to imagine what they're doing, say, with the beakers. And I've already have the rephrase on there, so hopefully it'll kind of give you a little bit of a hint of how to go ahead and solve this problem. But go ahead and pause your video, look at it, and try to figure this one out. Okay, so we're going to look at this, and I think the key in this is really making sure that you understand that they're talking about 12 milliliters of acetic acid in this case, and 38 milliliters of water are being mixed together. So then we have 12 plus 38 equals 50 milliliters of solution. So when they're asking about what's the percentage of the solution is acetic acid, we can look at this and say, what percent is 12 milliliters divided by the total solution? So let's go ahead then and we'll get that in there. So we'll say, all right, what is X percent is 12 milliliters divided by the total number of solution. And in this case, we'll look at this and get our calculator and go 12 divided by 50 is 0.24, 0.24, and excuse me, so I go back and get that. So I'll put my X on the wrong side. Okay. And so X equals 0.24. And since that is a percentage, then we're going to move this over and we add a percent and we say X equals 24%. And so thinking about that then, does that make sense? 12 milliliters out of 50 milliliters, 12.5 is 25%. So, yep, that makes sense. And hopefully this helps you with some of your homework problems. So remember to go back and you can use the way that the book does it, and the book also has examples and videos for you to watch, or if this helps you, then hopefully this helps as well.